Hello. Today we are going to go over Earth satellite orbits. So there are thousands of satellites that we have put up into space that circle the Earth for various reasons: navigation, communication, broadcasting, all kinds of things. But of these thousands of satellites that we have up there, some of them are going to be in different orbits than others. So let's take a look at some of these. So low Earth orbit, that's the first one. That is right here. You can abbreviate it LEO, low Earth orbit. This is the closest to the Earth, and we have most of our satellites in low Earth orbit. And the range there is anywhere from 2,000 kilometers or less, even down to like 120 kilometers above the surface. Still much, much higher than commercial airlines fly, but you can get pretty close to the Earth and still be in orbit. Some of the more notable things that we find there, we find the Hubble Space Telescope, and we also find the International Space Station. So the International Space Station, ISS, is in low Earth orbit. Makes it easier for astronauts to get to and from the space station. Next is medium Earth orbit, and that's this one here, this number 2, medium Earth orbit. That goes around where the low Earth orbit was really close here. Medium Earth orbit, that is anywhere from 2,000 kilometers to 35,786. You're going to see this number come up a couple of times, and it's important. Medium Earth orbit, we see a lot of navigation satellites. And the navigation, among other things, they might be used to help track where airlines are around the globe and making sure that they're not on courses to hit each other. Highly elliptical orbits, that's this one here, HEO, highly elliptical. That means sometimes the orbit comes really close to Earth and then it zips really far away from Earth before coming back close again and then going further away. Anywhere from 1,000 kilometers to 35,786 kilometers. And these ones are important because on both of these long legs, these long journeys here, going from the closest point to the furthest point, that satellite kind of maintains its position above the Earth in that one spot. And this is important, especially at the North and South Pole. They can stay at specific latitudes and stay at high latitudes. So it's kind of a specialized orbit. Now we have other satellites. And then we have our last one here, which is geosynchronous orbits. Geosynchronous is right here. It's number 1, geosynchronous. These are, these orbits go usually around the equator. They don't have to go around the equator, but they're really long orbits. They're way further out. They're out at 35,786 kilometers. The reason they're so far out is because this is the distance that a satellite can be sent above the Earth and specifically around the equator to maintain its position. So it is rotating, or its speed is the exact same as Earth's rotation. So if you had one of these geosynchronous satellites above, say, the country of Ecuador, it would stay above the country of Ecuador the whole time, because as the Earth spins, the satellite is going in that same rotation. So it matches Earth rotation. And it can be stationary over one spot. All right, so just a little bit about the satellites that we put up into orbit and some of the different categories. Thank you.